Find the GCD for three numbers, the greatest common divisor. But before we start, first notice this. If 3 divides 9 and 3 also divides 6, then 3 should divide the difference of 9 and 6. In other words, 3 should divide 3. That's a fact. We're going to use this fact in one of the steps along the way. So if 3 divides 9 and 3 also divides 6, it should divide their difference. And it does. So we're going to find the GCD for 96, 900, and 630. So we're going to use that fact that we just mentioned. So what we're going to do, the GCD for these three numbers would also be the GCD for 96 and the difference of these two numbers. We could have found the difference of any two numbers of the three, but we're going to go ahead and pick the biggest so that the numbers become smaller. So now, finding the GCD for 96, 900, and 630 is the same thing as finding the GCD for 96 and 270. It'll give you the same answer. So that's like shortening the work. So we concentrate on finding the GCD for these two numbers. And you could find the GCD using prime factorization, or you could use the Euclidean algorithm for large numbers. We're going to go ahead and go with the Euclidean algorithm for large numbers. It's supposed to be a shortcut. And this is the way it works. So you take these two numbers and divide the bigger one by the smaller one. You start the division. So 270 goes underneath the division sign, and you start the division. So you do your regular division. The remainder for the next division takes the place of the 96, and the 96 takes the place of the 270, and we're going to keep doing that till we get a remainder of 0. So this one takes this position, this number takes this position, and then do the division. After this division, the 18 takes the position of the 78, and the 78 takes the position of the 96. Notice how the 18 came up here, and the 78 went in here. So you do that division. Then the 6 takes the position of the 18, and the 18 takes the position of the 78. This time we have a remainder of 0. So your answer will always be the remainder before the remainder of 0, which is 6. So now we know that the GCD of 96, 900, and 630 is the same as the GCD of 96, 270, and they have a GCD of 6. That's the greatest common divisor, or greatest common factor, either way. For the LCM, we don't have shortcuts. For the LCM of three numbers, there are no easy algorithms. Therefore, we'll use prime factorization. So we'll use prime factorization. There they are. 96. This is a prime factorization of 96. This is a prime factorization of 900. And this is the prime factorization of 630. So notice I've highlighted by circling the primes. Once at the end you just have primes, that's when you're done. At the end there's only primes. Now we're going to go and collect them. So 96 equals 2 to the 5th. There were 5 2's, right? And 1 3 in that prime factorization. So we write it in exponential form. So it could be condensed, so we don't have to write the numbers, long lines of numbers. So 96 is this number, 2 to the 5th times 3 to the 1st. 900 is the multiplication of these numbers, and 630 is the multiplication of these numbers. Now for the LCM, the least common multiple, you have to choose each one of the prime numbers that is mentioned. So notice I mentioned the 5 is mentioned here, but it's not mentioned anywhere else. I still have to take it. So any prime that's mentioned in any of the numbers has to be written down. That's the first step. The second step, go to that prime number, for example, the 2, and notice this is 2 to the 5th, 2 to the 2nd, 2 to the 1st. You take the biggest power. So I take the biggest power the 2 appears with. Then I go through the 3's and I get the biggest power the 3 appears with. And then the 5, the biggest power it appears with, and then the 7. Multiply them out, and that would be your least common multiple, 50,400.